Let us now do a question. So again, this is a very popular question. Somebody gave me an array and asked me that, hey, implement two stacks in same array. Implement two stacks in the same array. Do you have any solution for this? So just be careful about one thing. Whenever I use the word stack, it means one end has to be fixed and the other end has to be flexible. Okay, I'll give you one solution and I'll ask you whether does that make sense or not. So let's say I had an array. I'm just going to draw that array vertically so that it looks like a stack. So let's say this was my array from index 0 till index n minus 1. Now what I can do is I can say that, hey, in half of the portion I will implement my stack 1 and in the remaining half I'll implement my stack 2. And for that I'll say that, hey, I will say that everything from here till here, which is from index 0 to let's say m, to index m, is reserved for stack 1, and everything from index m plus 1 to n minus 1 is reserved for stack 2, right? So in that case, what would happen is that the fixed end of stack 1 is index 0 and the fixed end of stack 2 is index m plus 1. Okay, so this is the way in which I can, so for this particular stack, so just think of it in this way. When you have a struct stack, let's say you have a struct stack and then you have this array of size n, and now you are supposed to implement two stacks within the same array. So how many top variables would you need? I would need two top variables, right? So top 1 and top 2. Okay, and how will you initialize your top 1? So for this, the end is over here, so you can initialize your top 1 to -1, and for the other one you can initialize its top 2 to n. So now what will you do? You will have a separate push function for pushing here and separate push function for pushing here, separate pop function here and separate pop function here. So you know, whenever you push something in this stack, then you will do top 1 plus plus, and whenever you push something in this stack, then you will do top 2 plus plus. And similarly, whenever you do pop here, top 1 minus minus and top 2 minus minus, right? Tell me one thing, will the overflow scenarios be same for both of them or will it be different? So when will you say this has overflown? You will say this has overflown whenever you see that s dot top becomes n minus 1, s dot top 2. Similarly, when will you say this has overflown? You will say this has overflown whenever you see that s dot top 1 has become equal to m, right? So their overflow scenarios are different. Can I say that underflow scenarios are also different? Actually they are, right? Because underflow of this will happen when this thing becomes m top 2 and this thing becomes -1, right? So that is the case for underflow scenario. Is something not so good about this implementation? What if you want to push into the first stack and it's filled? Yeah, right. So that was exactly what my question was. Is something not so good with this implementation? Just think of it in this way. Let's say this stack has become full and let's say this is populated till here. Okay, so let's say this is full and this is populated till here. After this, let's say you want to push something in stack 1. Will you be able to push something in stack 1? You will not be able to do that, right? But you have space left over, yes or no? You have space left over, still you are not able to push something in a stack. So is that not bad? That is bad. So here the space efficiency, this is not space complexity. Space efficiency means that whatever little space you have, how efficiently you are using it. So here you are not using them efficiently because you are saying overflow even though the array is not completely full, right? So that is a very important point. And if you realize this thing carefully, that is happening because both of them have different overflow conditions. Both of them have different overflow conditions. So what I can do is I can think of something like this. I can think of that, hey, there is a stack which is growing from here and there is a stack which is growing from here. So for this stack, the top initially was n, and for this, let me call it top 2, and for this top 1 was initially -1. And whenever you push something here, you do top 1 plus plus. And whenever you push something here, you do top to minus minus. So in this case, what will happen? In this case, can somebody talk to me about the overflow situation? How will you recognize overflow? The moment top 2 is equal to top 1 plus 1, it means that this is overflow. And this is common overflow for both of them. Yes or no? This is common overflow for both of them. In this situation, will it ever happen that some space is left but you can't push in one stack but you can push in the other? Can it ever happen? No. So this implementation gives equal opportunity to both the stacks for pushing, popping, whatsoever it is. So the space efficiency of this solution is higher than that. Okay.